Hi everyone. So today I'm going to be talking about my F5 work, which is CausalQA, a causal framework for question answering. So during this F5 work, I mainly worked on language models for question answering, and now I mentioned the word causal. So why causality? So language models have done tremendously well on question answering task, and question answering task is fairly important because it forms the basis for a lot of future applications for consumer-based businesses. So if language models are so successful, what's the problem? So language models are not interpretable. That is, many explanations have been given for their success, but they are not very useful, or the reason why the model has reached that conclusion cannot be interpreted. So one such explanation is attention, but this explanation has been debunked by the paper Attention is not explanation. So now causality provides a framework to make neural networks, or in specific language models, more interpretable using causal structural models. So before I move on to what that is and what our proposed model is, we can talk about the causal question answering data. And we have four things in the picture that is shown here, which is background, situation, question, and answer. So the background basically describes all the factors for a phenomenon or the causal factors for a variable. The basically what it means is that suppose, for example, we have our factor or variable is high blood pressure, then it describes all the factors responsible for high blood pressure. Situation describes the situation involving the variable whose causal factors are stated in the background. Basically, if the variable is high blood pressure, then it describes the situation. For example, if there are two people and their eating habits, then the question would be who has a higher risk of high blood pressure. So question is the question related to the situation, and answer is the answer to the question. So now moving on to the exciting bit, which is our proposed model. We can see a picture over here, which I'll go in step by step. The first one, if we see, we have three variables, C, S, Q. What is that? So C is the context or the background, S is the situations, and Q is the question. The S and Q go first to a module known as MHA, or multi-head attention. And this basically what it does is it finds the important sentences in the situation related to the question, which we now get as SW. We pass this SW to another multi-head attention model, and the context or the background is passed to it as a query. And we find the important sentences in the context based on this SW or this weighted situation. Now we get a new variable CW. So now if we see, we have CW and SW, and it's passed on to two green modules known as the GraphGen modules. And what this GraphGen does is it basically generates this causal graph. And this causal graph basically contains the parents and the final target variable which we're trying to predict. And basically it generates this graph which is GC and GS respectively, and this other variable which is HC and HS. So what are these? These are the hidden state variables from the graph gen, which is basically an embedding or another representation for CW and SW. These are now passed to something known as the inter module or the intervention module. The intervention basically is a change of a value in this hidden state such that it differs from the original hidden state that we got. So now we have two things coming out of this module, which is HC and H prime C and HS and H prime S. So HC is basically our original hidden state and H prime C is our new hidden state or intervened hidden state, which are now passed to a GNN, more specifically a GCN or graph convolutional neural network. And we get two things from this. The first one is a new embedding, which combines the information from these two. The second one is a set of probabilities that models this sort of relation. And this is done for both concatenated and outputted to see the difference. So, okay, how do we train this model? How do we incorporate such causal information for the model to learn a causal graph? We introduce something known as the causal loss function, which is heavily inspired from the paper DAG noteers. So this L is our loss function, which we have minimization of the cross entropy, which is the first term. It's basically how close our answer generated is to the answer in the data set. Alpha HA is basically something known as the acyclicity condition, which is given by this equation on top by the arrow points. And this is fairly important because this equation that we see here, this trace e raised to all these terms, maintain that the graph generated by the RNN is a causal graph or a directed acyclic graph, which is it has no cycles or self loops in the graph. Basically, one node cannot go back to itself. And that is fairly important to ensure that causal structure is maintained. The second term also is the same, which is the acyclicity condition. And third, or the last term, or the fourth term, is basically this difference operation over here. So what is that? So we see two probabilities, which is P observed and P inter, which is the probability of the observed minus the probability of the intervened, which we saw as the output coming from the GCN module. And now what we want to do is we want to maximize this difference. Basically, we want that if intervened, the probability distribution changes completely and it becomes very different from what we observe. And to max, and since this loss function is a minimization function, we minimize the negative of that so as to maximize the difference. Okay. So how are our results? Our results are actually fairly good, which is we observe comparable results to state of the art, such as unified QA, and perform slightly better as compared to another model known as DUTTA with fewer parameters. And this is quite good and shows potential in this following direction and possible work in this direction. So what is the future work? So we have talked a lot about the graph generation module, which is the most important module in this work. And how do we know that the graph that it's generating is a causal graph? So we need some sort of theoretical formalism for this RNN based structure or the graph generation module to show that theoretically the graph that it's producing holds all the properties of a causal graph. The second thing that we can do is something known as the causal mediation analysis for the graph generation model. Basically, we tweak a few parameters while keeping the others constant to see the effect of those parameters on the graph generation itself. And this is done at an RNN level. Of course, to concretize the results, we can test on more data sets. There are multiple out there like squad, race, and so on, and we can do our testing on that. And lastly, we can perform ablation studies on attention and graph generation. Basically, we tweak the parameters of this and see how our output changes by tweaking these parameters for both attention and graph generation. So that is all for my FIP, and hope you guys like my FIP and enjoyed the video.